Welcome to the Depth Dive. Today we're exploring a really dense theoretical physics paper by Rajkamal Shiromani.
Yeah, it's a heavy one.
It really is.
Like,
But our mission is to break down how redefining empty space could, solve physics' biggest mystery and maybe launch a fourth industrial revolution for you.
right, which sounds huge because it is.
Exactly. So let's start with a thought experiment. Imagine a completely empty box. Like, you pump out every single atom of gas, block out the thermal radiation, and cool it down to absolute zero.
Hmm,
You put that perfectly empty box on a scale. Classical physics tells you the energy inside is zero.
right, obviously.
But according to quantum field theory, that vacuum is actually buzzing. It has this quantum hum. So much zero-point energy that a single empty coffee cup could literally boil all of Earth's oceans.
Yeah, that's the prediction of 10 to the power of 112 ergs per cubic centimeter. But then if you look at general relativity, Einstein's framework for how the universe expands, it says the vacuum energy should be incredibly tiny, like almost zero, around 10 to the negative 8.
Okay, so let's unpack this. It's like one scale saying an empty box weighs zero and another saying it weighs more than the sun. How do we fix a math error that big? I mean, this is the vacuum catastrophe, right?
It is. It's literally the largest discrepancy in the history of science, a gap of 120 orders of magnitude.
Wow.
Yeah. And to resolve it, Shiromani's paper argues that we basically have to throw away the idea of an empty geometric void entirely. Like, space just isn't empty.
Wait, so if the box of space isn't an empty void, what is it?
Well, the paper introduces this idea called space constriction theory. It models space as a physical superfluid lattice.
A superfluid.
Exactly.
Yeah.
Think of it as a macroscopic Bose-Einstein condensate. So that is a state of matter where particles get so cold and packed together, they lose their individual identities.
Oh, right. And they act like one giant synchronized fluid.
Precisely. And when you introduce mass or extreme velocity into this fluid, the spatial lattice physically tightens. The paper calls this tightening an increase in space frequency.
Okay, wait. I'm trying to visualize this. If space is a physical fluid that tightens, what is the solid matter we see around us? Like, is it interacting with that fluid?
Actually, it goes deeper than just interacting. What's fascinating here is that this framework supports a zero-energy universe,
Meaning what exactly?
meaning the solid matter you see is positive energy, and the gravitational pull it creates is negative potential energy.
I see.
Yeah, so sum them together, and they perfectly cancel out to zero. The universe doesn't violate thermodynamics just by existing.
That is wild. Does that completely change how we look at Einstein's E equals mc squared?
Fundamentally, yeah. The framework introduces the Rajkamal constant, which is evaluated at about 1.65 times 10 to the negative 44 inverse newtons.
Inverse newtons, okay.
Right, but instead of focusing on the obscure numbers, think of this constant as a cosmic exchange rate between solid matter and vacuum tension.
A cosmic exchange rate. I like that.
Yeah, it dictates that mass isn't a solid object. Matter is just highly concentrated vacuum energy that is permanently trapped in a topological loop.
A loop?
Basically, the fluid of space gets twisted into a complex knot that can't easily come undone.
Wait, so matter is just a localized whirlpool in a cosmic fluid. Does that mean destroying matter? Like, what we do in nuclear fission isn't actually breaking a solid thing apart?
No, it's not.
It's just untying that topological knot.
You nailed it. Untying that knot relaxes the constricted spatial frequency.
Wow.
And then it releases the trapped energy back into the surrounding fluid as radiating photons. You are basically just smoothing out a ripple in the ocean.
Okay, but if matter is just a knot in this fluid, that shouldn't just apply to stars and equations. I mean, that has to apply to the cells in our own bodies too, right?
It totally does. It changes our entire understanding of biology in space. Just think about astronauts.
Right.
On long space flights, they experience severe IDG symptoms, bone loss, cardiovascular issues, space anemia.
Which we usually just blame on microgravity, right?
No, exactly. But this paper argues that human cellular machinery is exquisitely tuned to Earth's specific space frequency.
Oh, so leaving Earth's gravity lessens that spatial constriction.
Yep. The ambient frequency shifts, and their microscopic enzymes just fall completely out of tune.
Okay, here's where it gets really interesting. So space-sick astronauts are basically seasicker because the frequency of the cosmic ocean changed.
That analogy holds up incredibly well, yeah.
Yeah.
Their bodies literally don't know how to operate in the new rhythm.
That makes so much sense.
And understanding that cosmic ocean means we can build better ships to navigate it too. Manipulating this vacuum could actually lead to reactionless field propulsion.
I have heard of that, but how does it actually propel a ship without, rocket fuel?
So you can use something called the dynamical Casimir effect. By vibrating components, like piezoelectric crystals or microscopic mirrors, incredibly fast, you create tiny ripples in the vacuum fluid itself.
Okay.
This asymmetrically fluctuates the ship's mass, allowing the spacecraft to literally push off the tension of empty space.
Just push off the vacuum for interstellar travel. That is mind-blowing.
It really is.
So what does this all mean for you listening? To summarize our mission today, reality isn't an empty void. You exist in a vibrating, interconnected quantum ocean.
Right, that empty box on the scale from the beginning of our deep dive is brimming with the fundamental medium of existence.
Exactly. If you look at the space between your hands right now, it's not nothing. It's the fabric that makes up everything.
It completely changes your perspective on reality.
It really does.
Yeah.
And I want to leave you with a final thought to mull over today. If our DNA and our enzymes are perfectly tuned to Earth's specific vacuum frequency and spatial tension, could we eventually hunt for habitable exoplanets not by searching for water, but by scanning the cosmos for regions with an exact matching space frequency?